Hello and welcome. Today we're going to be taking a look at getting prepared for our first test on chapters 1 and 2. Beginning with problem number 1, we're going to list all the elements of that set that are of the indicated type. In this case, that type is whole numbers. I'm just going to circle these. So 10 is a whole number, square root of 6 is not. Negative 20, remember whole numbers do not include negatives. They do include 0. And 0 over 8 simplifies to be 0, so we would include that in our set of whole numbers. And the square root of 4 simplifies to be 2. So that's what we'd be looking at for the numbers that are whole numbers from that set. Next we'll take a look at which of these numbers are from the set of rational numbers. So I think I'll just cross off the ones that do not work. So square root of 6 does not work. It doesn't simplify to be a rational number. Negative 5, 0, 0 over 5, and the square root of 4 all work. Pi is not rational. Negative 4 over 0 isn't even real. It's an undefined value. And 0.14 being a terminating decimal is rational. All right, next we're looking at which of these are irrational. So negative square root of 4, that's actually negative 2, so that's rational. 3 is rational. Square root of 5 would be irrational. Negative 23, 0, 0 over 9, those are all rational. Pi is irrational. Negative 7 over 0 is undefined, and 0.64 is rational. So looking really just the square root of 5 and pi from that set that are irrational. You may remember this style of question from the quizzes. Again, there's a few different things we want to do here. We need to, first of all, just determine whether the equation is conditional, an identity, or a contradiction. But also don't forget to give the solution set. In order to get started on number 4 here, we would distribute the 2. We get 20t plus 12 equals 8t plus 60. In this case, it looks like it will be conditional because the t's will not cancel out. If I subtract the 6t from both sides, excuse me, I would also subtract the 12 from both sides since I'm getting the t's on the left. So we end up with 14t equals 48. Which would be good, except I'm just noticing now that this would be 8t, not 6t. So let me fix that real quick. So 8t, so then we would have 12t. That's going to work out better. So dividing by 12, we get t equals 4. So that's really my solution set. I also need to then say that this is a conditional equation. So number 5 really has the same directions. Again, we'll see what we get once we start distributing. So we end up with 16g minus 96 minus 16g plus 96 equals 0. So notice that the 16g minus 16g and then negative or minus 96 plus the 96, those will all cancel out, so we end up with the statement 0 equals 0. Again, I want to emphasize that 0 equals 0 is not the solution to this equation. This is 0 equals 0 tells us what's going on. So what happened is all the variables went away and we got a true statement. That means that this is an identity. An identity means that no matter what value we plug in for g, they're all going to work. So the answer would be all real numbers. In set notation, or interval notation I should say, we can write that just by saying negative infinity to infinity. Number 6 continues with that same set of directions. We need to determine what type of equation it is, whether it's a contradiction, an identity, or a conditional equation. So we start by distributing the 2 so we can see what we really have over here. Again, in this case, looks like the k's will cancel out and we will be left with 82 on the left and 80 on the right. So that being a not true statement tells us that this is a contradiction, and that means that there is no solution. Again, the quickest way to show that is with the symbol for the empty set. I do want to emphasize again that 82 equals 80 is not the solution to the equation. That is what tells us that this is a contradiction, and then we need to realize that for a contradiction there is no solution. For problem 7, we're going to solve this equation for p. So we have in our equation here, we're going to solve that for p. One of the tricks here is that we have p on both sides of the equation, so we want to get all the p's to the same side. I would probably decide to just subtract 3p from both sides. If I'm doing that, then I can go ahead and add 3 to both sides as well. Now I don't have any like terms to combine with anything, so we just get 3s plus 3 on the left and tp minus 3p on the right. So in this case, what we do is, since we're solving for p, we factor the p out of the right side. We're left with t minus 3 then. Then we have 3s plus 3 here. What we do next is to divide by the t minus 3. That will get the p all by itself. And so we end up with p equals 3s plus 3 over t minus 3. Now there is no reduction that can be done there. You could factor a 3 out of the numerator, but you cannot factor a 3 out of the denominator, so nothing actually cancels out. So just make sure you leave your answer like that. Alright, with problem number 8, we get into our word problems. Here we just have a rectangular Persian carpet, has a perimeter of 236 inches. The length of the carpet is 20 inches more than the width. So again, make sure you don't just use 20 inches there. And they want us to find the dimensions, so both the length and width for the carpet. Hopefully you remember our formula for perimeter of a rectangle. It's 2 times the length plus 2 times the width. We know the perimeter. We were told that's 236. And we're told the relationship between the length and the width. The length being 20 inches more than the width. So here we wind up with perimeter of 236, and then 2 times the length, which is being replaced with the width plus 20, plus the 2 width is what we get. We do need to distribute the 2. When we do that, we get 2w plus 40. We would combine the 2w, which would give us 4w. And then we would subtract the 40 from both sides. We end up with 196 equal to the 4w. Dividing by the 4, I can sneak that in here, divide by 4, we end up with 49. So that's the width. They wanted both dimensions. They also wanted the length. Lucky for us, we have this equation here. Length is 20 inches more than the width. So if the width is 49, then the length is 69. Of course, we can include units in here, so 49 inches and 69 inches. And it helps to make sure that that does actually work. You can check pretty quickly that it does. Okay, so next we have our investment problem. In this case, Marty inherited $70,000. She invested part at 9%, invested the rest at 11%. Total income from that for 1 year was $6,700. We want to find the total amount invested at 9%. I'm going to draw a quick table here. So let's see, we know that she invested overall $70,000. We know that she invested some at a 9% rate, so 0.09, and some at an 11% rate, so 0.11. Again, careful not to let that mess you up. Again, we don't use this area here for anything. Total interest earned was $6,700. We don't know how much she invested at the 9%, so I'm just going to call that A. So interest there would be 0.09 times A. And call it B for the 11%, so 0.11B. So this really leads us to two different kind of situations that we know. We know that the total invested, A plus B, has to equal $70,000. We also know that the interest from the 9% investment plus the interest from the 11% investment has to equal a total of $6,700. Now, so that gives us two equations with two unknowns, so we can use our substitution method to solve that. One thing I will do before I do that, though, is multiply both sides of this equation by 100, and I'm going to be a little lazy putting the parentheses around the whole thing, but that leads to 9A plus 11B equals 670,000. Now, it does give us a big number at the end there, but I think we'll appreciate not having to deal with those decimals at all. I would solve this top equation. Let's see, if we're trying to find the amount invested at 9%, I would solve it for B. So B would equal the 70,000 minus A. And so I can plug that in here for B. So what that equation looks like next, we would have 9A plus 11 times 70,000 minus A equals 670,000, which then becomes 9A plus 770,000 minus 11A equals that 670,000. Combining the A's gives us negative 2A plus the 770,000 equals 670,000. Subtracting the 770,000 gives us negative 2A equals negative 100,000. Dividing by the negative 2, we see that A is 50,000. And if you go back to our table, A was the amount invested at 9%, which is what they wanted. So, turns out, invested $50,000 at the 9%. And even though they didn't ask, that would mean that $20,000 was invested at 11%. So there we go. And then the last one for this page, we've got our kind of mixture problem. We're looking at how many liters of a 10% alcohol solution must be mixed with 30 liters of a 90% solution to get a 30% solution. Again, we can make another table for this. So in the left column, we've got how many liters of actual solution there. Well, we know there's 30 liters of a 90% alcohol solution. We don't know how much of the 10% solution that we will use. So that means the total would be x plus 30. So again, we don't actually know that amount, but we can summarize it in terms of x pretty quickly. Our goal is to get a 30% solution. So actual alcohol, I should give myself more room here, 0.9 times 30 0.1 or 0.10 times x and 0.3 times x plus 30. So it's similar but a little bit different than our investment problem. Again, notice we actually use this cell here, and then we can write this originally pretty easily without two variables for this one. So really just that right-hand column is our equation. So 0.9 times 30 plus 0.1 times x equals the 0.3 times x plus 30. Again, you can multiply both sides by 10 here. I think I will go ahead and do that. Just sneaking it in over here. Oops, not 100, 10. So that gives me 9 times 30 plus 10. No, sorry, that would be a 1x plus 1x equals 3 times x plus 30. So now I can, again, deal with this without all the decimals. We get 270 plus x equals 3x plus 90. Subtracting the x from both sides. I'll actually also subtract the 90 then. So we get 180 equals 2x. So divide by 2, we get x to equal 90. So again, the question was how many liters of a 10% alcohol solution? So we would need 90 liters of the 10% solution. Again, fairly straightforward to check that. 90 liters would give you 120 liters total. 30% of that 120 would give you the total amount of alcohol in that mix, which would be 36 liters. We know the 9 times 30, 9%, or sorry, 90% of 30, so it would be 27 of the 36, and then 10% of the 90 would be another 9, so it would add up to be 36 liters of actual alcohol in that solution. Alright, so looking at number 11, solving the inequality, given the answer in both interval and graph forms. In this case, I would begin by adding the 5a to both sides of the equation. If I'm going to add the 5a, I may as well subtract the 1 as well. That leaves me with a is greater than or equal to negative 6. So that's really my solution, but now I need to graph it, so negative 6 goes here, greater than or equal to negative 6 would go this way. So there's my graph. The interval form then looks very similar to the graph. It starts at negative 6 and goes up to infinity. Again, notice the bracket on the negative 6 because the equal to, but the infinity will always have a parenthesis. And here we have a compound inequality with and. Again, so we solve these separately. I would probably start on the left side here just by adding 6 to both sides. So we end up with negative 10 is less than or equal to 5x. Divide by a positive 5, so no need, or we would not flip the inequality. So negative 2 is less than or equal to x. We could flip that all over and say x is greater than or equal to negative 2. Do the same sort of thing here, subtract the 1. We get 9x is less than 18. Divide by a positive 9, x is less than 2. So we have x is greater than or equal to negative 2, and x is less than 2. So those should come together just fine. Greater than or equal to negative 2 would look like that. Less than 2 would look like this. Just where they overlap. So again, no arrows in the middle there, just a solid line connecting those two. Solid segment, really. Interval notation then would look like this. Very much like the graph, negative 2 with the bracket, 2 with the parenthesis. Here's another compound inequality. This one uses OR. Let's see, so they're kind of forcing me to deal with the negative here, so I'll subtract the 12x like they kind of want me to. Get negative 8 is less than negative 8x. Now when I divide by that negative 8, I do have to flip that inequality. So we get 1 is greater than x, which if you want to flip that around would be x is less than 1. The other side, again, they don't give me much choice right away, I just have to divide by that negative 2, which means I flip the inequality. So we get x is greater than or equal to 3. Again, this is or, so less than a positive 1 would go like this, or x is greater than or equal to 3 would be like this. Since it's or, that's perfectly fine. Now remember, when we go to write this in interval notation, we need to use two intervals really in order to write this. So we go from negative infinity up to 1, and we union that with 3 all the way up to infinity. So that's what our interval notation looks like for that one. Alright, here we have our absolute value inequality. The directions are a little bit long because they're written for an equation or an inequality. Notice that if it's an inequality like 14, then I want us to write the solution set in interval notation. They are not asking us to graph it, although I might anyway, just because then that's easier to go to the interval notation. We very first need to isolate that absolute value before we can do really our absolute value kind of process. Now I can see I have the absolute value is less than a positive number, so I can go ahead and set up my two inequalities. Again, I like to do the flipped and negative one first. Since this one is less than originally, then it's going to be and if you forget that, that's not a big deal. You can figure it out based on what you have at the end. Really only the one step here, subtracting 6. So we get h is greater than or equal to negative 15, and subtracting the 6 again, we get h is less than or equal to 3. And again, you can just visualize that graph, how it would go up from negative 15 and down from 3, and that's where they would overlap. So the interval ends up being negative 15 to 3, like that. Again, notice the brackets on both sides. And for number 15, we have our absolute value equation. Again, notice we first have to isolate that absolute value, in this case adding 5 to both sides. So we get the absolute value equals a positive 19. So again, since it's positive, that means we can go ahead and do our absolute value equation process. So set the y plus 7 equal to the negative, and also set the y plus 7 equal to the positive 19. Really not much to do to solve here, just subtracting the 7. So get negative 26 for one solution, and a positive 12 for the other. Again, very straightforward as far as checking to make sure that works. Whether you have a negative 26 or a 12, you add the 7 and they both get you to either a negative 19 or a 19. But the absolute value of both of those is 19, and then 19 minus 5 gives you 14. With number 16, we need to make sure that we isolate our absolute value first, so we would add the 9 to both sides. At that point, we get the absolute value of 7y minus 7 is greater than negative 4. Now, the issue here is our kind of process for solving absolute value equations and inequalities only work if we're comparing the absolute value to a positive. So since this is a negative 4, this is a special case. Now notice we're saying the absolute value greater than a negative. The thing is that if, there's only really 3 different things that can be inside this absolute value: positive, negative, or 0. If you do the absolute value of positive or negative, you still get a positive. Absolute value of 0 is 0. So the result from this absolute value is either 0 or positive. Well, those are all greater than negative 4. So this is always true. So we just put that in interval notation as negative infinity to infinity. Number 17 is similar to that, but kind of the exact opposite. Here we're saying that the absolute value equals a negative. Again, it just kind of depends on how you're comparing them. If we're, like in 16, when we said the absolute value is greater than the negative, that's always true. But here saying the absolute value equals a negative is never true. So the solution set would be the empty set. 18, another special case. Here we're comparing the absolute value, saying that it's less than or equal to 0. Well, it can't be less than 0, but the absolute value could equal 0, and that would happen if x plus 5 equaled 0. So we subtract the 5 from both sides, we get x equals negative 5, and that's the only solution to that inequality. If you can see what happens when you plug the negative 5 in there, you get the absolute value of 0, which is 0. Well, that is less than or equal to 0. If you wanted to put that in set notation, again, it would just be negative 5 in that set notation. And for number 19, we have the absolute value equals 5, so we can actually go ahead and set up our two equations here. 4m plus 2 equals 5, or negative 5 first, actually, and then 4m plus 2 equals positive 5. And it doesn't really matter which one is which, but I just like to have the negative one first. We'd subtract 2 from both sides, so 4m equals negative 7. Divide by 4, m equals negative 7/4. I would be okay with the decimal there because it's a nice terminating decimal, but at the same time you don't really need it. Subtract 2 from both sides here, we get 4m equals 3. Divide by 4, we get m equals 3/4. So there are the two solutions. Again, if you wanted to put it in set notation, it would just look like this. We'd have negative 7/4 and 3/4. And there we go. And then the last question, number 20, we have an absolute value equals an absolute value. That will be true so long as one of two things happens. Either what is inside the absolute values are equal to each other. So say that it's 10 and 10. Well, then the absolute value of 10 equals the absolute value of 10. That's true. But it will also be true if one of those is equal to the opposite of the other. Again, say it were 10 and negative 10. Well, the absolute value of 10 is equal to the absolute value of negative 10 because they're both 10. So we set up these two equations to solve. If I start over here, I would subtract the s from both sides. If I'm doing that, I may as well go ahead and add the 8 to both sides at the same time. So that gives me 3s equals 14. Divide by 3, we get s equals 14/3. So again, that's a repeating decimal, so may as well just leave it as 14/3. That's already reduced. Let's see, on the right side, we would distribute that negative first. We get negative s minus 6. From there, I'd probably choose to add the s to both sides. In that case, I may as well add the 8 to both sides as well. So we get 5s equals 2. So divide by 5, get s equals 2/5. And that's a nice terminating decimal, but again, I may as well just leave that in fraction form. So if I were to write that in set notation, it would be 14/3 with 2/5. That would be the set of all the solutions for that equation. Well, thank you for watching, and hopefully you found this to be helpful.